So recently, we did simplifying radicals. Today, we're going to go one step further with operations with radicals. So our operations with radicals, multiplying radicals. So your product rule, and we've kind of got into the product rule yesterday a little bit with simplifying radicals, just says that if both of the numbers are underneath the square root, they can be multiplied together. And then we also have an additional rule that says x times the square root of a times y times the square root of a, or excuse me, of b, let me use different letters, would be x times y outside the square root, and then a times b underneath the square root. And then we would simplify using the rules that we learned yesterday. So let's look at this one. So the square root of 50 times the square root of 2, that's like the a and the b in the equation that you see above. So if I multiply those back together, I can pull them back underneath one radical. So the square root of 50 times the square root of 2 is equal to the square root of 50 times 2, which is equal to the square root of 100. Well, if you recognize that is a perfect square, there's no need to do factor trees. So then that is equal to 10. Easy peasy. Okay. Number 2, the square root of 3 times the square root of 6. Well, if we put that all underneath one square root, then we have the square root of 3 times 6, which is the square root of 18. Now, that's not a perfect square, so we do need to go through what we did yesterday. Simplify our radicals. We always simplify. There's my pair of 3's and my leftover 2. So I have my 9 and my 2. They each get their own. So the square root of 9 is 3, and the square root of 2 is a decimal, and we're going to leave it alone. So the square root of 3 times the square root of 6 is the square root of 18, but we have to simplify that just like we always reduce fractions, and you get 3 root 2. Number 3, now this is like that second rule. So what you're going to do is you're going to do 3 times 2, and then you're going to do 5 times 10. Now the tricky part is then you have to simplify it. So this gives us 6 times 50. Now I need to kind of take a break for just a second, go over here, take care of my square root of 50, because I got to simplify it if I can. So we got to test it. 2 and 25, 5 and 5. There I have my pair of 2's. That's 25 and 2. And again, you may be getting to where you can do some of these shortcuts. So 5 root 2. So I need to come back up here. So 6 root 50. We say 6 root 50. What we mean is 6 times the square root of 50. So now the square root of 50 is actually 5 root 2. So I'm going to go up here and I'm going to replace that square root of 50. So it's going to be 6 times 5 square root of 2. Well, now I've got math I can do. 6 times 5, that's 30. So it's 30 root 2. So 3 root 5 times 2 root 10 goes to 6 root 50, which then reduces to 30 root 2 as the final answer. Now 5 root 2, this one's important because you'll see it when we do Pythagorean theorem. So 5 root 2 squared means 5 root 2 times 5 root 2. Now, if you do 5 times 5, and then you do root 2 times root 2, that's what we're going to do. So 5 times 5 is 25. Root 2 times root 2 is root 4, but the square root of 4 is 2. So we can simplify that. The square root of 4 is 2, and 25 times 2 is 50. Now you can type that in on your calculator, and that will do the work for you. Be careful with your parentheses. Make sure that you do 5 root 2, and then close your parentheses, and then square it. Or you can do 5 root 2, enter, and then square that, and get an answer, and you'll get the 50. Most common mistake is students want to square the 5, but not the root 2. And so most of the time students will get 25. Root 2 is the answer because they squared the 5, but they didn't square the root 2. Root 2 times root 2 is 2. That's going to be very important with what we're about to talk about. So while we're here, let's talk about that. So root 2 times root 2 is root 4, which is 2. The square root of 4 is 2. So the square root of 5 times the square root of 5 is the square root of 25, which is 5. So I hope you're starting to see a pattern. The square root of 9 times the square root of 9 is the square root of 81, which is 9. So how about the square root of 23 times the square root of 23? Well, I don't know what the square root of 23 times what 23 times 23 is off the top of my head, but what I notice is that in every other time, root 2 times root 2 was 2. Root 5 times root 5 was 5. Root 9 times root 9 was 9 at the end. So root 23 times root 23 is 23. Now that's a really nice shortcut to use. Okay? Some of these are harder than I actually want for them to be, so we're not going to do all of these, and I'm going to replace them with some others that will come out a little bit nicer and be a little more friendly to do. So we're not going to do this one, and we're not going to do this one. And then I want to change a couple of these. So let's do this. And we're going to change this one. Okay. I want to make them be like more like what they're going to be like when we get to a little further in the notes. So let's start with 10 over root 2. So here's the problem. You are not allowed, in mathematics, we're not allowed to leave numbers in the denominator, in denominators or fractions. So what I would call ugly numbers, imaginary numbers, radicals, you're not allowed to leave them in the denominators of fractions. And so what we have to do is we have to rationalize. This is actually what we would call dividing these fractions. So what we want to do is we want to multiply, but we're allowed to multiply by 1 all day long. Now, remember that 1 can come in many forms. 1 over 1 is 1. 2 over 2 is 1. 10 over 10 is 1. And so what I want to do is use what we just talked about square roots, to be able to get rid of the square root of the denominator. So since I have in number 1, since I have a square root of 2 in the denominator, what I want to do is I want to multiply by root 2 over root 2 so that it'll go away. Think about when we usually get a common denominator, right? If we're trying to do 1/2 plus 2/3, you would come over here and you would multiply this one by 3 over 3. You would multiply this one by 2 over 2. That's what we're doing. So think like you do a common denominator. Now we're just going to multiply across the top and multiply across the bottom. So 10 times the square root of 2. 10 is outside the square root. 2 is inside the square root. So they just say 10 times the square root of 2 like that. And then root 2 times root 2. Well, we know that root 2 times root 2 is 2. Now notice here. I have a 10 outside the square root, and I have a 2 on bottom being divided that is outside the square root. They both have to be outside the square root. Since they are both outside the square root, this 2 and this 10 will cancel to 5 and leave me with a final answer of 5 root 2. Okay? So let's look at this one. So I have a square root in the denominator. I need to get rid of that square root of 7. So I'm going to multiply by the square root of 7 over the square root of 7. Now notice the 3 and the 7 that are in the numerators. They're both radicals, and so I can multiply them together. So the square root of 3 times the square root of 7 is the square root of 21. Over the square root of 7 times the square root of 7. Go ahead, skip straight to that end point. Square root of 7 times the square root of 7 is 7. Now, notice that the 21 is underneath the radical and 7 is outside. It's not underneath the radical. That means that they cannot be simplified any further. That is the answer. Let's look at maybe this one. Let's do 15 over the square root of 3. So again, I need to get rid of that radical. So I'm going to multiply by the square root of 3 over the square root of 3. So 15 times the square root of 3, you just write that down again, 15 root 3 over. Root 3 times root 3, remember, is, we can shortcut that. Root 3 times root 3 is root 9, which is 3. Now, always look at your numbers on the outside. Notice I have 15 and a 3. Now, the 3 in the denominator cannot cancel the 3 underneath that square root because it's not actually worth 3. It's actually the square root of 3, which is 1.73. Okay, so, but I can cancel that 15 and that 3 right there. 3 goes into 3 one time, 3 goes into 15 5 times, so my final answer is 5 root 3. Now on number 4, what you could do is, see the 3 is okay in that denominator, but the root 2 is not. So I'm going to multiply the root 2 over root 2. I'm not going to mess with, I'll deal with the 3 in a minute, but I don't want to square it because that's just adding more numbers to have to deal with. So I'm going to multiply the top. I get 4 root 2, 4 times root 2 over. Now here's where you got to be careful. Okay, pay attention here. Root 2 times root 2 is 2. Remember, we talked about that over here. Root 2 times root 2 is 2. That one we're going to use a lot, so keep that one in mind. Root 2 times root 2 is 2, and 2 times 3 is 6. So that's what goes on the bottom. So be careful, don't just do the root 2's. Now, pay attention. Again, you've got a 4 on top and a 6 on bottom. Those can be reduced. 2 goes into 4 2 times, and 2 goes into 6 3 times. So my final answer is 2 root 2 over 3. Okay. Let's do, how about we make up this one, 9 over root 3. So think ahead. What should you do? Okay, we need to get rid of the radical in the denominator, so we do root 3 over root 3. So 9 times root 3 over root 3 times root 3 is 3. Again, always double check. 9 over 3 is 3. 3 root 3. Now, I kind of want to show you something, just a little bit of a trick that might help some of you. Do you notice that on number 1, it was 10 over root 2, and we got 5 root 2 for the answer. And number 3 was 15 over root 3, and you got 5 root 3. And then 5 was 9 over root 3, and you got 3 root 3. Now, it only works when the numbers that are, if you just look straight at the numbers, like the 2 and the 10, the 3 and the 15, and the 3 and the 9. 2 goes into 10, 3 goes into 15, and 3 goes into 9. So one of the things you can do is recognize it'll always work that way. So let me show you. Let's make number 6 be, let's make it be 15 over root 5. Now, this works when it's in this format, right? Whole number on the top, square root on the bottom. Now, this only works if this shortcut helps you. So if it doesn't help you, don't do it. But here's what you could do. I can look at that and go, well, 5 goes into 15 3 times, but I wasn't dividing by a 5. I was dividing by a square root of 5, so I'm going to throw a square root of 5 on the end. That happens every time. Notice, 2 goes into 10 5 times, so you wrote the 5, and then you had that root 2, so you wrote root 2. 3 goes into 15 5 times with a square root of 3 tacked on. 3 goes into 9 3 times with a square root of 3 tacked on. 5 goes into 15 3 times with a square root of 5. Now, if that doesn't make sense to you, I'll show you it still works, right? Multiply by the square root of 5 and the square root of 5. So we have 15 times the square root of 5 over root 5 times root 5 is 5. Well, 5 goes into 5 one time. 5 goes into 15 3 times, and see, either way you get 3 root 5. Now notice on 7 that doesn't work that way. On 7 you have the square root of 5 and the square root of 3. Those don't go into each other, and so you would multiply by whatever's on the denominator. So we have root 5 and root 3. That gives me root 15, because I can multiply those two together because they're both underneath the radical. And then root 3 times root 3 is 3. Now, this is different, okay? Don't go any further with this. Notice, this is not like 1 and 3 and 5 and 6 that we just did. Notice now the radical is on top. You're done. Once the radical is on top and everything is, there's no numbers outside, no coefficients in front of the 15, you're done. You can't simplify anything else. And 15 is underneath the radical and 3 is not. Okay, so we're finished. This last one, on number 8, we need to get rid of that root 3 that's on the bottom, so we'll multiply by root 3 over root 3. So we do top times top. Root 2 times root 3 is root 6. Be careful. Root 3 times root 3 is 3, and 3 times 2 is 6. Now, I have a square root of 6 on top, and I have a whole 6 on the bottom, so I can't do anything else. I have to leave them just like that. So just be careful with multiplying. Remember, you can multiply ones that are outside together, ones that are inside the radicals together. And then when you divide, you've got to keep that radical out of the denominator. That's the most important part. Ones like 1, 3, 5, 6, those are the most important ones that we're going to do.